Hello, welcome back to part 3 of income distributions. So in this part of the video series, we will demonstrate how to calculate the median of grouped data. Remember, in part 1, we started with a relative frequency table, and I showed you how to do a histogram, a cumulative relative frequency table, and also the ogive. In part 2, we looked at calculating the mean of group data. And in this part, we will look at the median. Oh, yes, and I almost forgot. We will also, of course, look at the gender pay gap in Switzerland for median. We have done this for mean in part 2. So we get really interesting data for this gender pay gap in Switzerland, which is relatively closely based on the real data. Again, I explained in the previous cases that I had to change the data slightly. I have to prepare it, but it's relatively close. Okay, so let's get started. So remember, this was the data we looked on in part 1 and part 2. So this is the data we always look on. It's the income distribution of female full-time employees in Switzerland 2020. So it's a relative frequency table with grouped data. In the first column, we have the different classes. So the classes are, so the employees are grouped into different groups according to their monthly income. So, for instance, here we have the group from making 3,001 to 4,000 francs per month. And these are 12% of the population of these female full-time employees. This part was what we calculated in part 2. Histogram we did in part 1. Mean we did in part 2. Ogive we did in part 1. And we also did the cumulative relative frequency table in part 1. So that's our starting point, the cumulative relative frequency table and the corresponding graph, which is called the ogive, and it's listed here. And again, what does it mean? Well, we have different classes, but we have now cumulative classes. So this class is all female full-time employees, which make up to 4,000 francs per month, or here up to 5,000. So the starting point is always 0, and we go up to a certain upper limit. For this reason, these percentages will always increase, so this function is an increasing function. Now, remember what the median is. The median is the income which a person makes if 50% of the population make less and 50% of the population make more. And now we know that in the group of those making less or equal 5,000 francs, we have 40%. So that means if you are making 5,000 francs, 40% are making 40.1% are making less than you, and the rest is making more than you. That means you are below median. If you go to 6,000 francs, then 60.1% of the population are getting less than you. That means you are above the median. Well, that means if you look at these two numbers, the median must be between 5,000 and 6,000, because 5,000 would be 40% and 6,000 is 60%, and you see 50% is about in the middle. So a very good guess in this case is 5,500. You can also see it on the ogive, so let me show it on the ogive. So what you do is you go on the ogive, you go up until you hit the 50%. So that's not really a line on this 50%, but you can see it, 50% is about here. So you're moving up until you hit the 50%. This is where your median would be. And then you go down and look what is it on the scale, on the monthly income scale. And you see it's right between 5,000 and 6,000, right in the middle in this case. So it would be 5,500. But if the numbers are a little less convenient, like in this example, so 40%, 60%, that's relatively easy to do. But let's say it's 45% and 60%. How do we calculate this median a little more precisely? So that's what we want to do. And for this, what we are using is we are using a little theory of straight lines. So what we are doing is we are looking at this ogive, which is a piecewise defined linear function. All pieces are linear. We look at this crucial linear part between. We rephrase it as a straight line function. So we don't look at the bending here. We just look at this part here. We call it f. And we are looking for where does this function f hit the 50% y value. And of course, for this, we need to calculate the function itself. And we use the 2-point given formula. So 2 points are given. What is a function of f? And then we solve an equation. So let me rephrase it again. The question is, where does a linear function through the 2 points x1, y1, and x2, y2 have f of x equals 50% or 1/2? And remember, in our example, x1 was 4,000, x2 was 5,000, y1 was 40.1%, and y2 was 60.1%. So this is our data we eventually put into the calculation. But this is our framework. And what we first do is, of course, we calculate the slope of this linear function f. Slope formula y2 minus y1 over x2 minus x1. So that's pretty simple. Again, we have these 4 points, 4 values given. So we calculate this m very quickly. Then, of course, we want to have f. And maybe in this case, we go with the slope point formula, which, remember, has this shape m equals y1, y minus y1 over x minus x1. So it's essentially like the definition of the slope, except that y2 and x2, the concrete values y2 and x2 are replaced by the variables y and x. But otherwise, it looks exactly like the definition of the slope. And we get the function itself, so f of x or y, by solving this for y. And keep in mind, m is given now, m is calculated. We calculated m in the first round. So m is given, y1 is given, x1 is given. So we solve this equation for y and therefore get a linear function y as a function of x. So if we solve this, and of course we solve it by multiplying the equation by x minus x1, distributing, so we get m times x minus m times x1, and then we have eventually add y1 to isolate the y on the left. So we get y equals mx minus mx1 plus y1. And again, keep in mind, mx1, y1 are constants. So this is a linear function in terms of x. This combination of these two values here is my b. So this is a function. And now, again, the function is known. All we need to do is find the x value for which f of x equals 1/2. So what we do is we solve the equation of f of x equals 1/2. And again, remember, f of x is this expression here. So we solve this equation here, where y is no longer part of it. We have x as a variable. We have m and x1 and y1 constants. Again, we calculate these values. We calculate m, x1 and y1 are given. And if you solve this for x, that's pretty simple to do. You bring this part and this part to the right, and you divide the whole by m. So you get x equals 1/2 plus mx1, so this is moved to the right, minus y1, this is also moved to the right, and we divide the whole thing by m. This value is a median of our data. Okay, so now let me do this calculation maybe on these cells here. So maybe I start right here. I need a few cells. So I need x1, I need y1, I need x2, and I need y2. And of course, these values x1, y1, x2, y2 are extracted from the data from the cumulative frequency table. So the y1 and the y2 are the last Y value which is below 50%, and the first one which is above 50%. So here is a 40.1%. So 40.1% is here. So maybe I write it in percentages, why not? And here we have 60.1%. And the X values are the corresponding incomes. So to 40.1% belongs 5,000. So 5,000 here and 6,000 there. So this is my data. And so maybe I highlight this a little, or maybe not, because it's not visible at the moment. So anyway, so this is what you fill in based on your relative frequency table. And then we have two calculated values. We have M and we have the median, or what is called X in this formula sheet on the right. And M, well, it's pretty simple. So again, you remember the formula. It's a difference of the y coordinates divided by difference of the x coordinates. So I write equal. I have to open a parenthesis here because we have a difference divided by a difference. So I open the parenthesis. I type in, I click in the values again. So y2 is here, minus y1 is there. I close the parenthesis and I divide by open parenthesis x2 minus x1. And again, you see very nicely Excel highlights the cells in color. So it says H41 minus F41. But again, it's a blue cell minus a red cell divided by the purple cell minus the green cell. That's our slope formula. So what do we get? 0.0002, a very small number, not surprising, because the difference of the y's is less than 1, and the difference of the x is 1,000. So we divide something less than 1 by 1,000. And now the median. For the median, we need just this formula here. This is a median formula. We need to plug in m, x1, and y1, and 1/2, of course. And it's a fraction again. So we go here. We type in equals. I open parentheses again because it's a fraction and I have a sum and difference in the top. Okay, 1/2. 1/2 is 0.5. Maybe I plug it in like this. Then we have m times minus m times x1. M is here times x1. So you see, I'm writing 0.5 minus blue times red. I think it is red. And then plus 1, plus y1, plus y1. y1 is here. And I close the parentheses and divide by m. Here I don't need parentheses because I just divide by m once. So I divide by the blue value again. The blue value occurs twice in this formula, so m occurs twice. It's okay. And this should be my median. So let's see what it is. Okay, made a mistake here, probably in the formula. So let's see. What is the problem? Yes, I see. You see it? I did a plus F1. I need to do a minus F1. So let me fix this. And this first one was a plus. So I don't know why I got confused here. So always check, of course, whether the formula is correct and also check whether it makes sense. 0.5 plus m times x1 minus y1 divided by m. So hopefully this now works. 5,495. And remember I said before it's about 50. It's about 5,500, right in the middle between 5,000 and 6,000. So it is about 5,500, but it's a little more precise than otherwise. So here, maybe I highlight this, make it large again. I highlight this here in yellow again. So we have the mean 6,209 and the median 5,495. Not surprising that the median is less than the mean. That's always true for income distributions because the histogram, if you look at the histogram, it's not a symmetric curve. It's shifted to the left. And for this reason, the median is always less than the mean in any real world income distribution. So this is also visible here. Actually, it's a lot less than the mean. So if you're making 5,495 francs per month and you are a female full-time employee in Switzerland, then you're right in the middle. 50% of the females are making less than you and 50% are making more than you. All right, let me wrap it up by looking at the gender pay gap. And remember, in part 2, we calculated the gender pay gap for mean. So this is this part. So I filled now everything out and colored it a little. So here, what you see is these are the means for the female full-time employees in 2006, 2012, and 2020. And these are the corresponding means for the males. And these numbers in red here are the percentage which women make less than male. So it was 21.9%, decreased a little to 20.2% in 2012, and 2020 it was 15.9%. And the amount that men make more than female is not the same number, obviously. So it's 28% in 2006, 25.2% in 2012, and 2020 it was 18.9%. So again, a decrease. And of course, the same we can do for medians. Remember, here this is female 2020 5495. So this is the value here. So what I did is I went to my machine and put in different data. And remember, the data was here collected: female 2020, male 2020, female 2012. So I just highlight these columns and copy and paste them to my machine, to my relative frequency table here. Of course, I plug it in here, and then this number will fall into place. So I do this 6 times for all these 6 different columns, and I get these values here. So again, you see all these medians are less than the means. It's also not very surprising. And the gender pay gaps are also smaller for median than for mean, and this is maybe not obvious why this is the case. So if you look at the median, the gender pay gap is a little less than if you look at the mean. Again, think about why this could be. Maybe it's a good topic to think about, and think about whether this is always the case. I don't think it is. Thanks for watching. Remember that for those of you who are interested in the mathematics of inequality, I have 2 more parts. Part 4 about Robin Hood index using the mean, which is discussed in part 2. And in part 5, we do Lorenz curve and Gini index. Bye-bye.